So yeah, first I just wanted to review. One of the challenges is remembering at each point in a deployment process or whatever you happen to be doing, the point in which you encounter a problem. You might be in different places on the file system on your own computer, or you might be at the point where the problem is on the remote server or somewhere in between, and knowing where each thing happens is important. So yeah, the sweet spot is it's something that's happening locally. And there's sort of two levels to locality. There's both it's my own computer and it's the same process where I typed Dallinger deploy or Dallinger debug. Most of deployment happens locally and is easier to troubleshoot, though that's of more relevance to the Dallinger core developers than it is to experiment authors, because it's us that's worrying about whether something's wrong in deployment. The exception to deployment being local is that the deployment process also makes some remote calls. It has to make calls to set up Heroku. It does a test of the Redis connection. It winds up doing a git push. The way your experiment code gets onto Heroku is by creating a Git repository locally on your computer, adding the Heroku server as a Git remote, and then pushing. And that's how it gets up there. And things can go wrong in any of those processes. So I alluded to the fact that even when you're running in debug, things can be less local suddenly. So in the process of running Dallinger debug, a bunch of stuff is copied just as if you were doing a remote deployment. This temp directory is assembled. I think you went over this a little bit yesterday. And then a Heroku local process is started. And to launch, there's a call to the launch route in this other process that starts the recruiter and instantiates your experiments and all that stuff. And the same process happens if you're doing a actual deployment, but the system is no longer, the remote system is no longer just another process. It's actually running on the other computer. So yeah, I broke this down into the three locations. Local system, local process is the easy one. It's your computer, single process. Local system, remote process is the launch route and everything that follows when you're running in debug mode. And this one is important because, unfortunately, the stuff that runs in the second process is usually the stuff you care about. It's your own experiment code. It's not running in the same process. And that presents a challenge for debugging. If you try to use PDB directly, it will freeze when it hits your breakpoint, but you can't access anything. And yeah, remote system and process is obvious. That's the thing is running on Heroku, and there's lots of challenges to finding out what's going on. So first scenario, this is a debugging strategy for local system, local process. I don't know if we talked about PDB at all, and if that's familiar to people. If it's not, it's a game changer if you haven't used it. You just add that at the point you want to inspect what's happening in the code, and it will stop execution, and you can inspect the value of variables. I actually wind up writing a lot of code this way. For example, I want to write a bonus function. I will just call an empty bonus function with a PDB in it, and I will have all the state that I'd have set up for me, and I can start seeing what's available. There are options, basic Python stuff. So I think we've improved the situation, but one thing that Dallinger does a fair amount of, even in the local process, is it makes subprocess calls to execute shell commands like git init, git push, Heroku commands, either Heroku local commands or remote commands, doing things with Redis. And there's potentially a tremendous loss of information. You'll have some complicated command potentially with lots of arguments, and if you typed that directly in your shell, you'd get a very informative error if it didn't work. The Python subprocess module will often just give you this. Your command returned a non-zero exit status, and that's all you get. I think for the most part, yeah.
One example where you might see that is if you try to run Dallinger debug in two separate windows, and the second time you start one, it will fail with a not particularly informative error. There'll be a big JSON blob somewhere that if you look through it, you can say, oh, okay, port 5000 was already in use. But that's the kind of example of this kind of thing where it's something going wrong in a bit of code that you don't really touch.
Yep. I think this has improved quite a lot. We now do some wrapping and some tricks to get the output, the underlying error output out and put it in the logs and in the console. But it's still possible that you might run into this, in which case my strategy is to stop execution right before that call would happen, and you can tell what the call is, and then you can, from that point, run the command manually yourself and see what the actual error is. Yeah, an additional complication is some of these commands depend on you being in the temp directory that now has the files that are being used. When you run Dallinger debug, and I think the deployment, Dallinger sandbox and Dallinger deploy also, one of the first things it will tell you is the path to the temp directory that it's created, where it's putting all the intermediate files it's going to work with, so you can cd to that directory and run the command there. Oh yeah, I have a bonus tip here. Did you talk about configuration, like the precedence and multi-file? Okay, so configuration values can come from a bunch of places, and they get assembled into a final list based on some priorities, and it can be a little hard to figure out what has come out of that whole prioritization process. So if you're having config problems, like it looks like I have value X set, why does it seem like value Y is being used? The resulting configuration after all the precedence has been resolved gets written to a config.txt file in the temp directory, and you can look at that to tell what the final configuration will be.
So that means that you go to the config.txt and see what happened there in that temp directory.
Yes, that's
just see what that's after assembly.
Right, it's the official.
It's the real one.
Yeah. Okay, so yeah, back to the problem I talked about a bit. Your own code, everything that you've written in experiment.py or models.py will all be executed after the launch route is called. And even if you're using Dallinger debug, that's going to be in a different process, so you can't debug it directly. What to do? So 3 suggestions. First is the obvious one. You can just add logging statements to see what's going on, output the value of variables X, Y, and Z. The next, which I had been aware of for a long time, but I always assumed it was going to be a nightmare to set up and use, is the remote debugger. I think Matthew actually told me, no, it's not. You should figure it out. So I will attempt to demonstrate that briefly. And the third, writing tests. I think if you have done testing before and like it, you can do it in Dallinger also. There are a lot of examples in Dallinger core of PyTest tests, and we have a lot of fixtures in there to set up typical things that need to be set up to run tests in Dallinger. If you haven't done testing initially, it can feel like, wow, this is a lot of time-consuming stuff, and I'm not sure I have the patience for it. But if you're drawn in that direction, I would recommend following that. Right. Yeah, I would recommend doing quite a lot of logging just as a matter of habit, partly just to verify that the code you think that's running is actually running, or if maybe you're not even getting as far as you thought you were. The experiment base class has a log method that you can override if you want to just call self.log and have it be very distinctive in some way. So it's easy to see your stuff in the verbose output.
So just another good reason to have lots of logging as a matter of course is usually you don't find out about a bug until you push an experiment out and real people start using it. And if you've got logging in your experiment already, you can look back at a real experiment and try and work out what happened. If you don't, you'll find yourself adding the logging in and running it again, knowing people are going to see the same bug, just to help you find it.
And the log thing, log string, it's gonna go to the log. Like I don't need to bother about inclusion, like include stuff.
I have found,
import stuff.
be interested to know what Matthew has found. I have found that, especially running remotely, the required logging level that you need to use to have your messages show up in the paper trail logs can wind up being high. Like I've had to resort to logger.warn or .error or something more than I would have expected.
That's familiar, but I don't remember exactly.
Yeah.
So just log.error or log.warning, just gonna do the trick where log string is not sufficient somehow.
Well, let's see. I guess there's 2 things you can do. If you're in the context of an experiment, you can do self.log, and I think that will always work. If you're using the logging module directly, you've done from logging import get logger, and then you're doing logger.info or .debug or something. I think info may not be enough. You may need to do .warn or .error or .exception, I think is like the
self.log.error warning.
Yeah, I think
it's just self.log should be enough.
Yeah, if you
let's
have
check this and get back to you because I'm
okay.
not 100%.
Yeah. All right, so let me see if I can do this on Matthew's computer. Probably not. Yeah.
Well, do you want me to?
Yeah, if you.
I'll get you set up and then you can demonstrate what you like.
So that thing you need still to do even if you log, even if it's local remote, right? So everything after the launch.
Remote PDB, you mean?
This, what you're talking about, the remote telnet thing, you have to do it even if it's runs in your computer.
Exactly, yeah.
Where should we put it? Add node to network?
Sure. Is it in your virtual environment?
I think so. I'll double check. We have to put in requirements, don't we?
I don't think so. I think when I was prepping this, I had to pip install.
Oh. It's this one, isn't it? Do you want to do your slides and then I'll jump into that when it's working?
Yeah,
Do you want
sure.
to talk about it?
Yeah, I guess I had a general point or argument I wanted to make, so I can make that since it's not on the slides, I don't think. So one strategy that I think is important is to, and it might take some steps to get here, but to do the troubleshooting as close to the problem as you can. So the worst case scenario is you are debugging your custom experiment method on the Heroku server by inspecting the return values from calls to Flask routes, something like that. You have the entire stack there, and you're not really sure where the problem is, or maybe you do, but the tools you're using to inspect the situation are too many and too indirect. If you can, you want to identify where the problem is, and if possible, revert to doing local work using Dallinger debug or similar. And if it's a Python problem, using the Python debugger in the context that's causing the problem is more rewarding than running multiple repeats of the experiment in production and looking at logs.
So here's where we have the fun of we're trying to do a demo that Jesse prepared on my computer.
Yeah.
So doubly difficult. Okay, so let's see if this works. So we've got here in the code, in the add node to network function that we've been talking about a lot, I've added this variant of the PDB call. Is that right?
Yep.
So instead of just PDB and PDB set trace, it's RPDB and RPDB set trace. And hopefully, when we start going in,
Yeah, looks promising.
yeah, so you notice here it just says loading, which you wouldn't really expect. You'd expect to. This is iterated drawing. This is the wrong experiment. Let's try that again.
Was the line recruiter equals who equals hot air?
So that was the thing that we used a couple of times yesterday when we were doing the sandbox deployment.
Yeah, I know about recruiter equals hot air, but it's a recruiter equals who equals hot air.
Yeah, there's like an extra.
There's a who, yeah, if you look at it.
Yeah, that's just wrong. Thank you.
Okay.
That probably would have caused problems.
Okay, so I got that to start. And are you sure you will always do the telnet in this address? I mean, how do you know it's not supposed to be the local address?
Yeah, by default, remote PDB will use that combination. If you
By 127, not 00. If my app is deployed in 100, 0000.
Forget what it does. Does the loopback address or something? 127.0.0.1?
I know what this is. This is the problem that I had the other day. Yeah. So it's made slightly more difficult for me because I am a glutton for punishment and I'm running this in a headless VM. So I keep causing myself more issues.
What does it mean to be a headless VM?
There's no UI, so I can only SSH into my VM. I can't look at it. But you may have noticed that when you were running experiments, it started up a new Firefox or a new Chrome, and that was because Dallinger debug makes sure that the Chrome session or Firefox session it starts up is completely isolated from the rest of your environment. And if you do it this stupid way that I'm doing it, that doesn't work. So you have to do the isolation yourself, and I always forget to do it. So, moral of the story: do as I say, not as I do. Right.
That's what you get for knowing how to do things.
Okay, I think.
So you might. My Mac didn't ship with Telnet, so you might need to install.
Okay, so here, do you want to talk where it stopped? Or?
Go for it. It's probably there in the...
Yeah, so here, this is where we'd expect to see that owl picture that we saw yesterday, but it hasn't come in. And if we have a look at the debugging information, the network tab of the Chrome debugger, if it will allow me to do this.
Yes!
Yeah. So you see down here, there's a request to node, which has not yet returned. It says that it's pending. So that means that this API call has just stopped and we're waiting for something. And if we go to the terminal, we don't see anything special. But
If you scroll up,
no,
it'll be there, I think.
I don't know. I haven't seen that.
Oh, okay.
So I don't know. But
So good.
if I open a new window, and maximize this one, if it will allow me.
Showing you
Computers.
the internals of.
Right.
Sorry.
So on this one, there you go. You can take over now.
So you open up another terminal.
Yep.
Use that command to basically remote into the instance of Dallinger.
Yeah, it's a thread in a subprocess of something.
So this is some inception level.
yeah,
Okay.
But what you get to do,
Yeah.
it's so exciting, is you get actually like self.non-participant. You can do that.
So
Right?
you can actually debug your code.
Yes.
What a revolution! How were you all doing it before? Was it just really hard and painful?
It was very. I don't think it was possible
But
before.
this pattern actually lets you do some really weird stuff. Like you can tell Heroku you want to open a port forward from your local machine to a production server. So you can do Dallinger Sandbox and still do exactly this.
That's crazy.
There we go. That's a better face.
No, I'm just obviously debugging is very important to to the loop of development, but it's crazy that you could do that on the Heroku server as well.
But so the same. Well, you will explain how to do it remote, right? So currently we're doing it fake remote.
Yeah. I'm not sure we've got a slide for that, but I can show you how to do it. It's very. I've only had to do it once in like 3 years. But yeah.
But if you imagine you have an experiment, right? And
Yeah.
you in a sandbox.
Yeah.
So you want to do the same thing.
I mean, Jesse's point stands, which is you should always try to do it locally because it's so much easier. It's faster and it doesn't cost you money to do it.
But imagine you get to an error in Dallinger, which is very hard to reproduce. Like we have in our experiment we have something that happens towards the end. It's a little bit hard, and it generates an error. So that error like crashed the whole thing, right? So instead of that, you could take the worker and put a trace there, and just wait for that to happen.
You could. Bear in mind that once you do that, the entire server can't really be used for.
Well, if you get like 6 workers, then one of them is going to be stuck, and eventually all of them, but at least one, and then you can actually.
And if you so this will just open port 4444, and if you Google Heroku port forward, there's like a one-line command you can do to hook up the app that you've deployed to be able to tell it into it.
Okay, we can talk about it later, right? I mean, that would be useful to know. I mean, just to know that it exists.
All right.
I thought you were going to have PDB.
Hmm?
I thought you were going to demo PDB.
Oh, I was. Yeah, I could have. Huh? I would do a bad job given the context.
Should I just talk back to what you did on this screen?
Yeah. Let's see. Oh, this is the browser. Hmm.
If you go back to the terminal, just talk through what it looks like so you've got an idea.
Yeah. Sorry. There we go. Can I scroll up? Yeah. See my mistakes. Yeah. So since PDB might be unfamiliar, remote PDB, once you're in it, it looks the same as normal PDB. It will show a little bit of the code in the context of where execution's happening. There will always be a line pointing to the code the line that is about to execute. And any variable that is in scope at that point can be inspected. So like node was passed in as an argument, so I can type node and its representation will be bounced back to me. If I can also call any method that's available on node and it will actually return the results and show them. This is why I wind up doing actually kind of a lot of development this way, because I don't remember the API for Node, and I know once I just get one, I can try it. You can also type dir open paren node close paren, and it will show you all the properties of Node. Yeah, very helpful and easy to self-teach, I would say. It's just there's a lot of instant feedback. Any points, specific points? No. Okay. Yeah.
Can you also set it up in a local IDE? So for example, if you're using PyCharm, that you basically use this.
I think so. I think all those tools have remote PDB support that I haven't used, but yeah, it's one of the things they boast about. There's some related tools. I think there's a RPDB2 I saw something about that looks fancier and more difficult to use, so I haven't bothered with it, but might be interesting. Yeah, I think I actually talked about this already. If you're drawn to tests, they can be really great. I mean, it's a nice way of, it's sort of the ultimate in shrinking the context and isolating one specific thing. You do some setup, you write a little bit of code that exercises one function or method at a time. You know where you stand because there's not a lot of extraneous stuff going on.
I have a question about tests. So, if you have a test that requires you to actually kind of create an input, so for example, you want to populate a network or stuff,
Yep.
then you probably, your idea would be to kind of call the nodes as, like, because I'm in Python, not in JavaScript, right? So,
Right.
so I have to actually call the routes with I can just emulate the JavaScript side, right?
I would even go a level below that. So rather than calling the route and having, unless you're testing the route, I would just say the assumption is I have a network with 2 nodes, or in a network with more than 1 node, I have some method in my experiment that's supposed to return the one with the highest value. Say they're infos and they have contents and you want the one with the highest value. I would just, in Python, instantiate a network, add nodes to it, and then that is the context in which my experiment is going to be existing. And when I call this special give me the highest info function, that should be the minimum context that I need to exercise that. Then you know you're not, yeah, it's just, it keeps the context as small as possible, I guess, is the argument.
But you generate the network, like you don't
Manually, yeah.
manually.
Yeah, and PyTest, if you're doing the same creation again and again for different scenarios, the PyTest fixture system is helpful for capturing a bunch of setup in one call that you can then inject into your test context. And there's a lot of examples of that in the Dallinger test suite. There's examples of just about every kind of test in the Dallinger test suite, from, I think we even have some Selenium robot tests that actually drive a browser, and then we have tests that test the routes through the Flask routing system, and then we have a fair number of more.
This exists in the actual Dallinger test.
Yeah.
Also the grid universe experiment, which I think is a public repo now.
Yeah.
That has got a large number of tests. It's a pretty scary demo because it's a very big experiment with lots of detail in it. But that's got a lot of testing as well.
Which one?
Grid universe. If you want to see what it looks like to iterate on an experiment for about 18 months to 2 years, about 30 hours.
That's about right, yep.
Can I ask you a question? Imagine that you inherit from a class or something in Dallinger. Presumably you have a test for that, or for a method in that class, whatever. Do you recommend to adapt those tests, or is it a good idea to do that?
Generally, I would say if you are inheriting from a class, you
I mean extending, right?
Yeah.
Inheriting and extending.
If you are changing a method that is tested in Dallinger core, that's probably a good place to start to write a test. It might save you some time. If you're not changing it, then don't worry about testing the things that you aren't touching, because you can trust that the test to do that.
Okay, so this section is troubleshooting if things are already running on Heroku. And I think, we added something to this by introducing the remote debugging on Heroku. I haven't done that, but sounds trivial relatively.
Looks like this slide didn't update one time, doesn't it?
Yeah, it looks a little drafty. But there's my hand wavy questions about what level of logging you need. I think there's some unanswered questions there.
Because earlier, didn't you say that experiment log always works?
I did claim that.
Yeah. So I think what happened is this slide didn't get saved in one of the drafts.
Yeah.
Maybe we edited it offline or something. So.
Okay.
We'll tidy that up.
And just to clarify, this experiment.log, is it just a single log method, or does it have levels within it, sort of info and warn.
Experiment.log is just a single method.
And, okay.
Yeah. I think it calls print and then flushes standard out. So it's not much more than print, but a little bit more.
Before it would be possible to use the Python logger.
Yeah.
That would the output of the Python logger at a given level, I don't know, warming, whatever, and land in the paper thread.
Yes. Yeah.
So which would you recommend for us to do as a matter of course? This logger.
I usually use the logging module.
Okay.
Yeah. Yeah, I think logging is an area that could be improved in Dallinger. We've got a bunch of ways to do it. In fact, I just noticed this last example.
Is it no?
This turns up db.logger. So you import Dallinger db and then you use its logger for some reason. There must be a reason, but I couldn't tell you why. I think what would be nice is if we had a standard way of logging, and if you could control the level with config.txt instead of changing your logging throughout the code base. You just, okay, I'm done. I'm just going to downgrade the logging once in config.txt, but we don't have that yet.
Sorry, how is the regular interaction between logger and database? Even if you run it in debug mode, does depending on the configuration, does it land on some table on the database?
No, no.
This is your responsibility.
Just
to
logging.
store.
Yep. Yeah, I thought this was worth mentioning.
Yeah, that's cool.
A lot of the time when I've been looking at paper trail logs, it's to debug someone else's experiments, and sometimes there are complications with granting permissions to logs. At some point, I think I was looking at the Heroku documentation and I found this Heroku logs command, and if you have Heroku installed, you can just run it, and it doesn't have the same, paper trail has search filtering and stuff, but just running Heroku logs directly will show you most of the same stuff in your terminal, and I often find that more useful than dealing with paper trail.
It's not going to show you the entire log from the beginning of the universe. It's going to show you what's going on now, right? Right?
Yeah, I think it's run without any arguments. It's like the last 500 lines or something. I often wind up using the -t option, which will continually update. So as things happen, you'll see new output. So yeah, you might like that. Okay, last section is cleaning up. This may be primarily relevant to running Dallinger debug. So one thing that can happen is if you aggressively kill your debug session, you can wind up with various processes continuing to run. Heroku local could be running, I forget what else, there's a few. Gunicorn server can be running. If you just Control-C once, it might take a couple seconds to die, but it will do its cleanup. If you repeatedly hit Control-C, it will override the controlled cleanup, and then you do wind up with zombie processes. And if you have, once you have them, it can be hard to start another debug session. So if you wind up in that situation, you have to do something to look for the leftover processes and then kill them.
Yes, I have a question. So all those things that created in a temp folder, they just accumulated on my computer forever? Or they delete it now and then?
Up to the operating system, I guess. They wind up in var something, 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 and probably.
I don't remember.
Okay, so whether I was wondering whether I have like all my experiments since the creation of the world? Probably.
It's specifically placed in that temporary directory where it is because that's where the operating system asks for stuff that, like, it wants to have no, it doesn't want to provide any guarantee that that stuff is going to be kept around, and so it is the standard place to store that.
But it's like, it isn't something that I need to care about, like, I'm launching lots of experiments. Do I need to, like, go there and periodically delete everything?
Yeah, it's a good question. I mean, you don't need to, and standard practice is to never think about it ever.
Mm-hmm.
The question is basically, if you have taken up your entire hard drive with the contents of just these temporary experiments, will you ever need to clean it out? And I think that's OS dependent.
Some OSs also remove it, right? When you reboot, they will remove parts of the temp.
Yeah, which is fine. Like, there's it's not needed for anything. So.
It doesn't seem that there's tons of.
Yeah, I mean, it would be
things
pretty
actually.
impressive. Like, I think we should be happy if somebody managed to run so many experiments and test things out so much that they managed to fill their hard drive with. I mean, the only time that could happen, like, more quickly than you'd expect is if you're storing huge amounts, like a large number of assets, like video assets in your experiment folder. Where the best practice is not to do that, because anything in that experiment folder is going to get pushed to Heroku. And so if, for example, you had a 1 gigabyte video that you were showing to participants, it would be better to store that on something like S3 and have them download it directly rather than do it through your server.
So deployment will take forever, so that's indicative. I think now you have some warning where when the Dallinger folder exceeds a certain size.
There was somebody who ran into that issue, and that they were actually storing lots of assets
Like if you
in their
like on the
folder
Heroku
because
or any of the words with Heroku
Same.
don't show up.
All right.
All right, I think this is the last slide, or nearly. So remote apps. I think this is fairly new. So you can check all the running Heroku apps that are registered to your Heroku ID by running Dallinger apps. And it takes a few seconds, but it'll display them all. And it includes the UID that you use to kill them using Dallinger destroy, which I think is on the next slide. Yeah, so Dallinger destroy will ask you if you want to expire associated hits, and I think it will now it assumes that they're not in the sandbox, but if it doesn't find them, it will suggest to you, might they be in the sandbox? I didn't find any hits. If you specify the sandbox option, then it knows to go look in the Mturk sandbox and expire them there. That's it.